Hello friends, in this session we will be talking about how to find slot angle. Let's begin. See here, before speaking about slot angle, let us try to understand what is the meaning of mechanical angles and electrical angles such that it will become very easy. Anyways, you please see here. For example, if I have a stator, let us say this way, right? And let me consider two poles. And let me call this as N1 and S1. N1 S1 means what? Fundamental poles, right? Now see here. For example, if I have a stator conductor here, let us say, right? And now I am rotating this rotor with a speed of omega in this anti-clockwise direction. Now you please tell me, see here, you please tell me, as of now, how much is the induced voltage here in this particular stator conductor? 0. As of now, induced EMF here is 0. Why? Because this is interpolar axis. This is lying in interpolar axis, right? Here, the flux density here, influenced here, is going to be 0. That is the reason why, as of now, induced EMF here is 0. What will happen after some time in the sense, when I rotate these poles, rotate this N1 and S1 by 90 degrees, when I rotate these poles N1 and S1 by 90 degrees, then what is going to happen? N1 will come here, N1 will come here, S1 will go there. Is it right? So when N1 is here, now see here, how to find induced EMF here, direction of induced EMF here? Just do nothing. See here, this is going to be the flux by, because it is N pole, outgoing flux. Outgoing flux is there. Now with respect to my field pole, because see, field pole is moving in anti-clockwise direction, which means with respect to my field pole, this has to move in clockwise direction this way. So this is the flux. Motion of the conductor is by thumb. This is going to be the induced EMF. Induced EMF is going to be dot. Dot means what, sir? Positive maximum, right? So you please tell me here, what has happened when my rotor poles rotated by 90 degrees, EMF changed from 0 to positive maximum. Now since this flux density distribution is sinusoidal, EMF is also going to be sinusoidal. So see here, let me call this as E conductor, EMF induced in the conductor. See here, how it is going to be there? Let me consider E conductor, right? You please tell me, what happened here? As of now, induced EMF is 0. When this N1 is here, S1 is here. After rotating the rotor poles by 90 degrees, here positive maximum came. Induced EMF came, right? Then further, if I rotate this by 90 degrees, means this N1 comes here and this S1 goes there. Rotor poles only, right? Rotor poles only I am talking about. So if N1 comes here, S1 comes here, again it will be under interpolar axis. So again after 90 degrees when I rotate it, it is going to become 0. EMF is going to become 0. Right? Then again when this N1 comes here and this S1 comes here, again after further rotating by 90 degrees, what is going to happen? This is under influence of south pole. So it is going to be what? Negative maximum. So this is going to become negative maximum. Again after 90 degrees, this is going to become this way. So if you see what has happened here, for a two-pole machine, when my rotor poles complete one revolution mechanically. This is mechanical rotation, right? When my two poles complete one revolution mechanically, electrically one cycle of induced EMF is produced. This is one cycle, electrically it is produced, right? Yes. See here, one more time. When two rotor poles, when I have a two pole structure, what is happening here? When these two poles complete one revolution, mechanically, induced EMF in this conductor completes one cycle. Getting my point, right? See here, why? Because when this mechanically when my rotor was rotated by 90 degrees, what happened? Positive maximum induced EMF was there. Means 90 degrees in mechanical, 90 degrees also in electrical we have got, and these are electrical angles, so I can also replace this as degree electrical also, no problem. Why? Because these are electrical angles, right? Anyways, let us think of four pole machine. See here, now let this be stator, right? Let me have four poles. Shaft key. Why N1 S1 here? Because heteropolar structure, already we have seen. Anyway, see here, let me rotate this by omega, speed omega. Now let me have a stator conductor here. Now let us try to understand. See here, what do you think about this axis? Here if you see, there are no poles, there is no influence of flux here, hence it is going to be interpolar axis, right? So if it is interpolar axis, as of now, induced EMF here is going to be how much? 0. So as of now, if I try to plot this one, see here, let this be degree electrical. As of now, it is under influence of what axis? Interpolar axis. So here, induced EMF is going to be 0. As of now. What happens when I mechanically rotate my rotor by 45 degrees? If I rotate my rotor by, because see here, if this is interpolar axis, no, this is also again interpolar axis only. Why? Because there are no poles here. This is also going to be interpolar axis only. Now you please tell me, when my rotor poles are rotated by 45 degrees, when my rotor poles are rotated by 45 degrees, what will happen? Maximum induced voltage will be there here or not? Yes, because this N1 will come here, this S1 will go here, this N1 will come here, this S1 will go here, right? Then it will be under what? Influence of maximum flux density of north pole, and then by using our right hand rule, we can easily find that it is going to be a dot polarity. So now you please tell me, what has happened here? When I rotate mechanically by 45 degrees, when this one rotates mechanically by 45 degrees, what happened? There was 90 degrees, or we can say positive maximum came here. Am I right or wrong? Now see here, let me write down 45 degrees mechanically. If I rotate the rotor poles by 45 degrees mechanically, I got from 0 to positive maximum, right? See. Initially, when N1 was here, S1 was here. When N1 was here, N1 was here. What happened? When N1 was here, S1 was here, right? This was interpolar axis. So, as of now, induced EMF is how much? 0. After rotation by 45 degrees mechanically, what has happened? This conductor got positive maximum voltage. Then again, see here. Poles, as of now, induced EMF here is 0. When rotated by 45 degrees, it is going to be positive maximum. Again after rotating by 45 degrees, what is going to happen? It will be under influence of interpolar axis, which means again it is going to be 0. Again after 45 degrees, it is going to be 0. So if you see here, this is going to be 0 degree, this is going to be 90 degrees, right? Electrically, if you see. So 45 degrees rotation of my rotor poles, 45 degrees rotation of my rotor poles mechanically will produce 90 degrees electrically. 90 degrees electrically. Why? Electrically, why, sir? Because it is induced EMF, electrical induced EMF, right? So 45 degrees rotation mechanically will produce 90 degrees electrically. Now you please tell me what is going to happen here when this rotates by, let us say, 90 degrees mechanically. If it rotates, then what is going to happen when it rotates by 90 degrees? Here 180 degrees will come. See here, as of now 0. After 45 degrees, positive maximum. After again 45 degrees, which means total 90 degrees of rotation. 0, 45 degrees, 90 degrees. 90 degrees again. What is going to happen? Interpolar axis will come here, which means it is going to be again 0. So 90 degrees mechanical will cause me 180 degrees electrical. Right? Now see here, just compare, see what has happened here. See, yes, it is right. See here, for a two-pole machine, if you see, for a two-pole machine, this was N1, this was S1, N1 S1 this way, or you can say this way, N1 S1 this way, right? When I rotated mechanically by 90 degrees, what happened? 90 degrees electrically came here, because as of now it is going to be 0. This two-pole I am talking about. As of now it is going to be 0. Then after 90 degrees, what has happened? After 90 degrees, what has happened? It has become, here I've got positive maximum induced voltage, which means it has traveled from 0 to 90 degrees. 0 to positive maximum is where 90 degrees only. Right? So here if you see, mechanically if I rotate by 90 degrees, I get electrically 90 degrees only. Which means mechanically if I rotate one revolution, I am going to get how much? One cycle. One cycle of induced voltage. Mechanically if I rotate this once total, then I will get one cycle of induced voltage, right? Right, because say here, as of now it is going to be 0. After 90 degrees, what is going to happen? Positive maximum induced voltage. Again after 90 degrees, what is going to happen? 0. Again after 90 degrees, here it is going to be again negative maximum. Anyways, you have got the point, right? So one revolution mechanically here of rotor poles produces one cycle electrically, right? So now, but here if you see, what is going to happen? 90 degrees mechanical produces 180 degrees electrical. So you please tell me, 360 degrees mechanical will produce how much? 720 degrees electrical, which means one complete revolution of this 4-pole machine, this is 4-pole, one complete revolution of this one will create how much? 2 cycles. Why? Because angles are getting doubled. If you see here, why? Because here if you see, when I rotated this pole by 90 degrees, then I got induced EMF to be positive maximum. Whereas here if you see, when I rotate this by 45 degrees only, I am going to get 90 degrees here, which means angles are going to be doubled, right? So here if you see, here will produce what? 2 cycles of induced voltage. And this is going to be for 4-pole. Now, you please tell me, if for two pole, one revolution creates one cycle. So for four pole, it is going to be two cycles. Now you please tell me what will be the same for p pole structure. For p pole, let us see. For p pole, if you see here. If I combine these two, or by some observation, what I can understand is that degree electrical is going to be p by 2 times degree mechanical. How it is coming, I will tell you. Believe me, don't worry. See, degree electrical is equal to p by 2 times degree mechanical. Ask me, sir, but how it is possible? Why you are saying this way? Let us see. See here. See here. Let us try to apply this here so that we will try to understand it. See here. See, if you think of two pole, if you think that P is equal to 2 for a two pole machine, if you think P equal to 2, what is going to happen? I am going to get degree electrical equal to 2 by 2 times degree mechanical. Just replace P by 2 here. So you will get degree electrical is equal to degree mechanical. Am I right? So you just see here, degree electrical is equal to degree mechanical or not? In the sense, when mechanically I complete 360 degrees, I get 360 degrees completed here electrically. One revolution means same only, no, 360 degrees only. If you don't believe me, you please see here. See, this was N1 S1. When this completely rotated by 360 degrees, when my rotor poles completely rotated by 360 degrees, I got 360 degrees of induced voltage here. Why? Because when these rotor poles rotated by 90 degrees, I got 90 degrees of induced EMF, which means what? It is going to be 360 only, which means degree mechanical is going to be equal to degree electrical for a two pole. Now let us try to verify the same for four pole. See here, if I put P equal to 4, if I put here P equal to 4, then what is going to happen? Degree electrical is going to be 4 by 2 times degree mechanical. Right? Which means what, sir? 4 by 2 is what? 2 times. So degree electrical is going to be 2 times degree mechanical. But you will say, sir, how? Just verify this. See here. See here. Yeah, it is okay now. See, in case of 4 pole, what has happened here? 45 degrees mechanically when I rotate, I get 90 degrees electrically. When I rotate by 45 degrees mechanically, when I rotate the rotor poles by 45 degrees mechanically, I get 90 degrees electrically. Or when I rotate the rotor poles by 90 degrees mechanically, I get 180 degrees electrical, which means angle is going to be doubled or not. So you please try to replace this there, in the sense, if you want, for example, degree electrical, right? So degree electrical is, let us say, let me consider 2. What I am saying is mechanical 45 degrees, right? Mechanical 45 degrees if you place, what do you get here? You are going to get 90 degrees only. So this is going to be electrical degrees 90. 90 degrees means mechanically it was 45 degrees. Mechanically 45 degrees, but electrically it is going to be 90 degrees. So from now, whatever angles and all we have, whether it is slot angle or any angle, those angles has to be what? Always electrical angles only. Why? Because we are interested in induced EMF. Anyways, let us try to understand how to find slot angle now. By the way, see here, this formula which is there, degree electrical is equal to P by 2 times degree mechanical. This formula is very, very important. Let us see how it is important. This formula is going to be very, very important in terms of exams as well and for understanding purpose also. I hope you have understood this whole thing, right? Yes. Now you please tell me here. Now you may ask me, sir, but yes, we have understood it. Yes, degree electrical is equal to P by 2 times mechanical degrees, right? Because all of this analysis and all we have done. Anyways, now you please tell me here. See, now we have seen Now see, we have seen that degree electrical is going to be P by 2 times degree mechanical. Right? This is for degrees. Now you please tell me how much is the total mechanical degrees here. If I think of slot angle, if you see, if when we talk about slots, right, let this be stator, right? So we are going to have slots here this way, somewhere like this. We are going to have the slot. However, actual slots and all, we will see them. These are going to be the slots, right? This is how the slots are going to be there, right? Here, all slots are going to be there. Now, I am interested in slot angle. Now, what I am saying is that slot angle also has to be what? Has to be electrical degrees only. Has to be also in what? Electrical degrees only, right? Electrical degrees only. Why? Because induced EMF which is there, it is going to be in electrical degrees. Anyway, see here. Now, you please tell me how much is the total electrical degrees here? How much is the total electrical degrees here? This is the electrical degrees we don't know, but we know that if for example, if I see this one, this way, right? So I have to rotate total. If I want that complete cycle has to be there, no? So mechanical angle I know. Mechanical angle has to be what? 0, 90, 180, 270, and it is again going to be 360 degrees, right? So mechanical angle I know. Total mechanical angle for the stator, what is there? Total mechanical angle is going to be how much? 360 degrees. So you please put it here. Yes, 360 degrees total, right? So total electrical degrees if I think of, see here. Total degree electrical if I think of, so it is going to be P by 2 times degree mechanical. Mechanical degrees means how much, sir? Mechanical degrees is going to be 360. So if you think of 2 1s are 180. So total electrical degrees is going to be P cross 180. So total electrical degrees here is going to be P cross 180 degrees. Now you please tell me, what do you mean by P into 180 degrees? If you think of this P into 180 degrees also represent what? This P into 180 degrees also represents that one pole brings 180 degrees. In the sense, if you only have one pole, no? One pole. See, just try to understand it. If I replace this P by 1, which means one pole means, or I can say one pole means 180 degrees electrical. Means one pole brings 180 degrees electrical, or you can say one pole represents 180 degrees electrical. You may tell me, sir, but yes, we have understood this. Yes, now total electrical degrees is going to be P into 180, because here total mechanical degrees is going to be how much? 360. Total mechanical degrees, circle, total mechanical degrees is how much? 360 degrees. But now total electrical degrees, if you think of, why? Because EMF is electrical, no? So I have to think about electrical degrees only. So total electrical degrees if you think of, it is going to be how much? P into 180 degrees, right? Now if total electrical degrees is P into 180 degrees, then how much is the slot angle? How much is the slot angle then? See here. What is slot angle? First of all, let us say. Let me this as the center, right? So these two adjacent slots. Distance between these two adjacent slots, electrical angle between these two adjacent slots is going to be slot angle gamma. So if I am interested in this one, then if I know total electrical degrees, then just by dividing by number of slots, I can get this gamma. Am I right or wrong? See here, this is total electrical degrees. How much is the slot angle then? Because it is going to be between what two slots? This way. See here, this is going to be the total electrical degrees, right? Now what is the electrical angle between two slots? This much. This is going to be the total. This is going to be the total, out of which only slot angle. So just by dividing this total electrical degrees by number of slots, I will have slot angle. So slot angle is going to be how much? Total electrical degrees upon number of slots, which is nothing but equal to gamma is going to be total electrical degree. Total electrical degrees is how much? P into 180. So gamma is going to be P into 180 divided by number of slots. I hope this whole thing is clear. This is what is about slot angle. Thank you.